Everyone's section 9.1, and this is going to primarily be about extracting roots. But I'm going to start with just a definition of our square function or quadratic function and look at it graphically just for a moment to kind of show, as we head into these solving problems, what the geometry is behind when we solve an equation. A little bit later in the section, we'll do a bit better job on graphing, but this is just going to kind of be an introduction. And so our squared function or quadratic function is, its most basic form is this y equals x squared. And that's the graph I have right here. If I have y equals x squared, if you think about putting some values in, -1 squared would make 1. So that's where we're seeing it being positive on both sides, because that square is going to take negatives and make them positive. 0 squared would make 0, 1 squared would make 1. And then 2 squared would make 4, so then you can see it's nonlinear. It's going to climb faster and faster as x increases. So let's take a look at what that will look like in a problem down here. And if you have any troubles getting 1 through 3 in the computer, I made a short little screenshot video of me entering the answer on one of these. So for this one, we're asked to graph y equals 3 minus x squared. And we're supposed to complete this giant table, which I wish they had made it like this big or even that big, but they made it that big. And then we'll use the drawing tool to graph the equation. And so you'll see down here, there's 2 things to click on. One will be for the dots and one will be for the parabola. And so for here, let's get our table filled in. -3 squared would be 9. 3 minus 9 is going to be -6. -2 squared will be 4. 3 minus 4 will be -1. -1 squared will be 1. 3 minus 1 will be 2. And then 3 minus 0 is 3. And you can see from here on out, it's just going to repeat these values because the square was making it positive. So it'll come out the same on either side of the vertex. So that would be 2, -1, and -6 again. And so then the way the directions read, it tells you to graph all these dots first. It's way harder if you graph all the dots first. So what I would do is, to graph the parabola, you're going to need to click on the vertex, which is either the highest or lowest point, which in this case, and actually all the cases on this homework, it's going to be on the 0, just because there's none that are translated. So when x is 0, y is 3. And then you'll just need to click on one more point to get the graph of the parabola. So if you clicked right here, then it would draw on the rest of the parabola for you. So let me cut away and do that, and I'll come back. Okay, so it looks something like that. Again, you'll get that just by clicking on 2 points. One of them does have to be the vertex though. And then to go get full credit, it's dumb, but they make you graph all 7 points. So once you have the parabola, then go ahead and click on this one, because then it's super easy to go back and fill in all those places. You just look, okay, -3 is right there. There's -2, there's -1, 0, 1, 2, and then 3. So you're just basically clicking on the graph, and that will speed up that step a little bit. So then we're going to use the idea of graphing to solve a few equations here. And so what this is asking us to do is graph the parabola in part A, so that's this first one. And then what they're doing is setting it equal to some value. And then we're just going to use the graph to see what would make it come out to 3. So basically we're solving by graphing. With this one, so for here we're not given a table to fill in, so we have to make our own. Again, we only need to graph the vertex and one other point. So if x is 0, y is 0, and that's going to be our vertex. And again, our vertex on all of these is going to be on 0, at least for this course, and next quarter they can move around. And then because this is a 1/3, it makes me want to put a 3 in there because I'm going to get easy math. So 3 squared would be 9. Actually, let me write that out. So if I do like that, 3 squared is 9, and then 1/3 of 9 gets me back to 3. So if I clicked here and here, it would draw in that whole parabola for me. So I'll just get that other side, and it looks something like that. So that's part A. And then what part B is asking is, where is that going to equal 3? And so what equals 3 is basically the y, because this is y equals 1/3 x squared, and y equals 3, and they're setting those 2 things equal. So what x's do I put in to make this come out to 3 is basically the same as if I just kind of think of drawing a line through the function at 3, and I just have to read down to see what makes that happen. So when x is -3, I plug that into this thing, and I get 3. Or when x is, oops, that should have a negative there, +3, if I plug in +3, I also get 3. So this one's the same idea. So this first one will get graphed. So when x is 0, 9 minus 0 would be 9. So that's going to be my vertex. And we'll just grab when x is 1, because that'll be easy enough. That would be 9 minus 2 is 7. And so when x is 0, y is 9. And when x is 1, y is 7. And then again, the computer will fill in the rest of that for you, but you would have symmetrical points, so it would be here and here. Let me fill in what the computer would draw. So there's what you would see on the computer. And then for part B, it's asking for where does this equal 1? And so there's our y equals 1 right there. And we just kind of trace down, we can see when x is -2, if we plug that in, we get y equals 1. Likewise, if x is 2, if we plug that in here, we get, it would be 9 minus 8, or 1. Okay, so that gets us to solving quadratics by extracting roots. And to do that, we're going to use something called the square root property of equations. And what this says is if I have a squared equals b, what I can do is I can root both sides of that and undo the square. So given a squared equals b, if I take the root and then that plus or minus, I get a equals plus or minus root b. So what this is saying is a could be negative root b or positive root b. And the reason for that is if you think of something like x squared equals 25, there are two values that make this true. -5 times -5 would make 25, as would 5 times 5. So when I take the root, I have to allow for both possibilities, the positive and negative roots. So when we're solving using the square root property, what we're going to want to do is isolate the quadratic term to make its coefficient 1. So say in this example, I had something out front, I'd want to get that by itself, and then we use the square root property. And then it may be we need to simplify a radical. So here I got square root 25, so I would want to make that plus or minus 5. So this first one here, x squared equals 49. Let me remind you that if I factor this, I would get x plus 7 and x minus 7. And what this should have two answers because I have two x's. So if I do this by extracting roots, I'm going to have square root on both sides. And here's that plus or minus that I would get from the two separate factors. And we'll actually see that coming up in the next section. So plus or minus 49 would be plus or minus 7. You can see here if I put a -7, it comes out to 0. If I put in +7, that would also come out to 0 for that factor. So here my two solutions are x equals -7 and x equals +7. This one, let me rewrite that over here. And so that y squared up in the numerator, I can also think of it as just multiplying. And then to get rid of this 4/3, I'm going to multiply both sides by the reciprocal, because what I want to do is I want to get this isolated. And then here we're going to have 24 over 4. That reduces to 6. And so root both sides, and y equals plus or minus root 6, or y equals -√6 comma root 6, depending on how they have it formatted. So for number 6, we want to isolate the squared, so we're going to bring the 350 over, and we'll have y squared over 2 equals 200, and then we'll multiply both sides by 2 to get the square by itself. And y squared equals 400, and then we can root both sides. and y equals plus or minus 20. And so again, that in the answer box, if it has y equals, you would have negative 20 and 20. These next couple of the same idea, it's just these ones will come up to decimals. So this first one, let me write that a little bit bigger. So here we bring the 3a squared over, because again, we want to get our a squared, our squared term by itself. And we get negative 4 equals a squared. And if you notice, so if I write that the other order, it looks a little bit better. So there are no two numbers that multiplied, well, there's no number that multiplied by itself makes negative 4. If I do 2 times 2, I get 4. If I get negative 2 times negative 2, I get 4. And so if you think about, in terms of the parabola, when we were graphing a squared plus 4, we would get something that looks like this. And so we're not getting any intersection points down here at the x-axis, and that's what extracting the roots is finding, is those x-intercepts, or those zeros. And so that's why sometimes we have no x-intercept, is because it's above or below the axis. For this one, let me write that bigger. So here we want to isolate the squared term. And that will get us on this side 1.6t minus 76 equals negative 49. And then from there we'll add over the 76. So 1.6t equals 27. And then divide over that 1.6. Oops, I dropped my squared up here. And so now I have t squared equals, that came out to 16.875. And now to undo the square again, I use my root with my plus or minus. And then this asked me to round to 2 decimals. And so when I threw that in the calculator, I got negative 4.11 and then positive 4.11. Okay, and then last we have a few literal formulas where we're solving for a given variable. We did this earlier in the quarter, but now we have square roots available, so that lets us solve for squares as well. So for this one, we have v equals 1/3 b squared h, and we're asked to solve for that b, which is squared. So the first thing I'm going to do is get rid of that fraction. So we'll multiply both sides by 3, kills off that. And now I got 3v equals b squared, over h, I was anticipating. So I'm going to divide the h on both sides. And I think I'll write it the other way just because it looks better. And now that I have that down to that squared being isolated, I can root both sides. And this one happens to be for where b is greater than 0, so I don't have to worry about the plus minus on that. So b will equal the root of 3v over h. This last one we have d equals 8 plus cv squared. And that should say for v right there. So I will move the 8 over, so I'm going to subtract the 8 on both sides. And I have d minus 8 equals cv. And then we will divide the c. So we've isolated the squared, and again, I'm just going to write it in the other order because to me it looks nicer. And now this time, the way the answerable box will work is they'll have that plus minus in front, and so you'll take the root of both sides, and while on paper we'd have to write that plus or minus, it's already there. So for typing into the computer, you're just going to type d minus 8c all into the radical.